So I'd say I'm an architect and architectural conservator, and that kind of sums me up in many ways on how I approach, how I feel excited about built environment in general. I'm very much an architecture geek, but I'm like a science nerd. I'm looking at building materials at a very microscopic level when I'm looking at buildings.
Hey everyone, and thanks for listening to another episode of Buildings 2.0. Today, I'm speaking with Charu Chaudhry, Associate Principal at Thornton Tomasetti. Charu, thanks for chatting with me today.
Absolutely. My pleasure.
Share with us your background. So before you were an Associate Principal at Thornton Tomasetti, you were just a young girl growing up, appreciating the built environment. What was that like?
Oh, it was wonderful. I graduated as an architect in India. And when I finished college, I was working in, regular building industry. I did not have the background of historic preservation or existing buildings in general. That was not a part of my education at that point. I got involved into working on 10th century Buddhist monasteries in India. Just right after school, when a professor from school came to me and said, well, we are embarking on this study. It's a research project. Would you be interested in joining the team? And without thinking a second thought, I said yes. I did not know where it was on the map. And I said, well, 10th century buildings, that's exciting. And I just left the world of reinforced concrete and went to this journey of understanding adobe, some of the most fragile buildings and constructions and materials, braving the world of climate change up in the mountains of India and holding some of these communities, indigenous communities that carry a cultural significance for us. And my time there was intermittent for I kept going back and forth for 5 years there. I worked on three monasteries dating back from 10th to 12th centuries. And I did a lot of advocacy work and revenue generation for the work that was supposed to be done. I got involved with various organizations as part of my work there. And after that, I got some internships with ICOMOS, British Council of India, and National Park Service in the US here. And as part of my internships, I was an exchange student. Went back and forth to different countries and then, learned from established people in this industry, understanding material science, understanding, how buildings behave in different climates, different situations. And after that, I went back to school to get my master's in architectural conservation. So I'd say I'm an architect and architectural conservator, and that kind of sums me up in many ways on how I approach, how I feel excited about built environment in general. I'm very much an architecture geek, but I'm like a science nerd. I'm looking at building materials at a very microscopic level when I'm looking at buildings.
In your years of experience, do certain principles or tactics stand out? Perhaps to use your 10th century, monastery example, are there things builders did back hundreds of years ago that stand the test of time? How did they think about materials and putting buildings together that perhaps has evolved over time, and maybe we could actually take a pointer or two from back in the days?
A lot of things have changed in terms of, material science, construction technology. Older buildings presented simpler materials with more challenging issues of durability. And frankly, the buildings I saw very early on in those adobe monasteries were that the material that you can kind of easily discredit as fragile and undurable if prepared correctly or if used correctly in a building system can really last thousands of years. What we see now is that there is a lot more complexity into material science, into making building materials has gotten more sophisticated. Building technologies have gotten more sophisticated. It's simpler building like an adobe, which wasn't supposed to receive water. They were meant for cold and dry climates. However, since almost 5 decades or so, the climate in that region has changed dramatically and receiving periodic rainfalls. So even when a building like Adobe, which was not meant to receive rainfall, has been enduring rainfall for more than 5 decades, tells you that materials often exceed the expectation when they are maintained properly. And with small amount of upkeep, the lifespan can be extended significantly. And the lifespan is not an end of destruction. End of destruction of a building is not as finite as we kind of think now. For now, the buildings are made for, let's say, 100 years or 50 years. There is a lifespan tagged to it. Before that, it wasn't that thought. When we build for life. And I think that is something that has negatively shifted in a way that we are tagging like a lifespan to everything. In terms of, I would say there are a lot of technologies that have improved in terms of science. I follow that quite regularly, the science of new building materials, the science of conservation of existing buildings. That is very exciting for me. Some kind of materials I don't feel that excited about because I'm a natural person. I like to see materials that are close to, natural elements in the world that I can identify with. When materials are too synthetic, I feel skeptical about that. I feel skeptical about, giving them a durability factor, if you say so.
Are there active or previous projects that stand out to you as an example of success? I imagine when you approach a project where it's historical and there's some significance to it, I'd imagine you have to balance between some of the modern needs and requirements together with like how do you preserve, right? What was special about this? What frameworks do you use to think about this, the design process, and how do you balance between the two?
Yeah, it is. It's the core of my existing. This question is the core of my existence. It's something we battle on project to project basis. My work is focused on renovations, reuse, and restorations of existing buildings. Right, whether they are being adaptively reused for a new purpose or they are being enhanced for their comfort levels or performance levels, or just the buildings are falling apart and have to be preserved. So there is a lot that goes into that thinking besides just, well, let's fix the building. We look very carefully in analyzing. So analytics, building analytics and materials understanding form the core of any decisions on how to improve or enhance their performance for the next X many years. I think of it as, so looking at the surface, it looks like it's an ocean to traverse because it's like, well, where do I begin? I have this building. How do I go about it? But actually, I like to break this down into droplets of water because otherwise it is an inundating adventure to embark upon. So I look at this as assemblies. One of the projects that I cannot say the name of, but it's a big institutional building in very early modernist building. It stands on, unique kind of a plaza looking at the building, which was kind of a modern building, kind of appreciation space. The modernist movement was, if you look at a lot of modernist buildings, they stand on a plaza, which was the appreciation place. So we were looking at this plaza overlooking this historic building, and there were issues of accessibility and the fact that the plaza was leaking and deteriorated and just falling apart. it was lined with historic materials, and the way this slab and the construction of that assembly was, there's not enough space to kind of play with the levels to do thermal upgrades like put insulation or another kind of system which kind of gives a more of redundancy for moisture management within the system. So those are the kind of issues that are very exciting for me because I love challenges. So looking at these archaic assemblies and seeing, how can I intervene? What can I possibly do to juxtapose these new elements that I want to put and enhance, upgrade this for accessibility, have good ramps and slopes, upgrade this for, material durability, make it watertight, and also make it pleasing for people to walk around it. So all these are great questions. And I think in terms of plaza, the issues are really like, thermal upgrades. So there are ways to, we think creative ways of, creating these vapor barrier lines within existing assemblies, which does not interfere with the top surfacing materials. In other words, go under the assembly because we can play in the interior space below. In that case, that really worked out for us. Besides, we had to do some minimal disruptions around the site to include a more updated waterproofing system. So thinking creatively in how to inject those new materials into the assembly without disrupting too much of the surface of the assembly is how we think about. Older buildings don't give us a lot of redundancy in their systems. They're very honest, they're very open. So there is not too many layers to it, which is what I like, that honesty of expression. So working through these issues, for example, another building we were working on, and it's a 18th century row house where some of the buildings on the side were demolished to create a new tower for residential financial district in Manhattan, where there are these pressures of growth. So the older kind of smaller buildings got demolished to create a residential tower. And while the construction activity was happening, even though this building was temporarily shored and protected, the construction activity induced so much stress in the building that the walls started splaying open and the ground started subsiding. So here you see a really 18th century vulnerable building really fighting for its life. To me, that was a very meaningful pursuit in, in attacking that issue in bite-sized pieces. First was, it's almost like being in the ER and stabilizing the patient. Like, just don't fall apart. We'll restore you later. Just right now, we need to keep you like holding on, keep breathing. So that's what we did. We attacked it with some really emergency temporary shoring so that the walls are not completely falling apart. And once we got a handle on, how much vibrations are we allowing this structure to endure, once we brought that down to a sustainable level, we delved deeply into what we can do about these walls that have suffered a lot. So, as you know, it's an old brick wall. There's not much to it except brick and mortar. So we kind of found ways to do injection grouting there with compatible materials that, induce that homogeneity back into the structure so it can endure. The principles of all the buildings are actually really simple. It's homogeneity and no voids, right? The voids are giving places for water to stay. So just eliminating those simple things enhance the durability of that wall. So that's what we did there. And once we stabilized the structure, controlled the vibration, stabilized the walls, then we started restoring some of the components, windows, cornices, roofs. That happened later, but before we kind of tackled some of the very emergency issues. So these pursuits are meaningful in a way because now I walk by that building. It's a school occupied by a school construction authority. I see little kids walking in and out of the building, and I look at it and I said, these little souls have no idea this building was falling apart, but I was there. So these are some of the, meaningful aspects of my life. Sorry, I got digressed. I don't remember how we began this question.
I'm fascinated because, the way that you speak about it, it's almost surgical in nature, right? Where there's a component of just understanding or just diagnosing like what is there. And then there's another component of determining like what should be, like what should we do. Talk to me about the mechanics a little bit. Like when entering into a building, one of the things that certainly I and my team has learned is it's actually really difficult to get an accurate set of drawings for any existing building, let alone for example, a 10th century monastery. What are the parts, pieces, equipment, ingredients, dots that you have to connect to even properly diagnose what is going on? How do you start that process?
I mean, you hit the nail on the head, and this is kind of the bane of my existence where if we are starting on a new project and there are no drawings to begin with, it's tough. I wouldn't say that it's like we can roll with it, because to understand buildings, buildings are a lot materials, but also it's engineering, it's mechanics of it. So understanding how the spaces are connected to each other, how the sections are, what the levels are. This is really important components to diagnose what's going on with the building in terms of, how forces are moving, how stresses are concentrated in certain components and on. So if there is nothing, I think like there are traditional ways to kind of start measuring buildings and, start making drawings. But I've grown fond of doing laser scans of buildings now. These are very efficient. We can do interior scans, exterior scans. I also like using, drone imagery collected in that's kind of it's so nice to see that these images capture a great level of detail, and the images can be stitched together in some kind of an ortho mosaic, and that presents a building. It depends what we are working on, because for some buildings, if the work is on the exterior, so understanding the exterior facade in detail is very important. So having those kind of imagery is really interesting, because then you can scale things, you can understand things, you can really go into great detail to see the condition of components and how components are connected. I have grown fond of the ways to scan and the ways to get information out of buildings if nothing is there to begin with.
Do you find in the design process, so once you've accurately scanned or captured the information, are there specific tools or processes in the design process you find helps kind of better frame how to approach the challenge? I imagine once you start, you've got a host of different considerations from, how are we doing right by the building in its original intention, but also some of the emerging challenges like between sustainability, some of the kind of new regulations going into place. What are the different tools and processes that you kind of take in the design process where you're stitching it together once you kind of understand, okay, here's what is, now let's determine what we should do about it?
It's a very interesting question, because there are lots of tools to kind of do data collection and understand what do we have at hand. But the analytics right now is still very kind of thought oriented. It's very much, there are small tools like ComCheck off the top of my head. It's where you just give a quick analysis of, what are the requirements in, per codes, and then take it from there. I think after that, after we establish these parameters using ComCheck, there's one analytical tool that I like, I have really found success with, is if there are thermal upgrades desired in the building with archaic assemblies. I would say that one tool we often use is understanding the dew point in the masonries. and doing this kind of hygrothermal studies of existing envelopes. It's a lot about how the envelope is performing. So while we do certain upgrades, thermal upgrades to the walls, the roofs are much easily understood because it's about stopping the vapor. It's easier without the need of complex modeling. It's easier and more established. However, when there are walls in question, there's a lot of, something that we need to think about is what is the state of distress of the wall at present? And when I upgraded for thermal value, is it creating more distress in terms of, vapor drive? And is it going to create mold and other issues in the building, more damp in the building, or am I solving that issue? So one is that. So hydrothermal studies are really important for it. There are other issues also, I would say, depending on the kind of issues you are encountering. Something I've used is finite elemental analysis in our analysis to understand stress concentrations. This is especially if structures are being modified for something else. For example, in another project we're working on, when buildings evolve over time, there are new components that are added, some components are removed, and there's this whole archaeology that we are undigging basically to understand what are the bare bones, what is the bare structure. So what is the impact of those decisions on when we remove something? It's through finite elemental analysis, we can understand those stress concentrations that the building is enduring. So another thing I learned recently was this is more of an issue in modern buildings, but also certainly any building, is the issue of air leakage, not necessarily just water leakage. Sometimes the buildings perform well underwater. However, air being very fine and easy to move through building inconsistencies can find its way in many ways and manifest sometimes as humidity, as, warping of the floor panels or wall finishes disintegrating or something, or, in many ways this can, or just building drafty building. So this was like a big postmodern tower in Midtown Manhattan. In looking through air leakage issues, we found that some of the simple analytics of, understanding air movement through building can give us great deal of information. A simple camera like infrared camera can talk volumes about where the inconsistencies are within the building envelope. So I'm a fan of using these simple tools and techniques to get a handle on bigger issues and kind of take it from there. There are more complex analytical tools like computational fluid dynamics and other kind of modeling softwares, which also have a very unique place in our industry. And I'm mesmerized that now that we have these tools and we use these tools, we gain so much more understanding of how this organism is behaving with the outside environment. Where is it that I want to keep the outside environment as out, and I want to have a controlled interaction with the outside environment? I think those are the core kind of values, but how to assess that, I do fall back on some of these modeling softwares. I would, however, caution to whoever is using these softwares modeling, it's fine to use it, but define your problem first. If we are not defining that problem, we are just kind of swimming in the ocean of data, not knowing where we have to go with it. I think defining that problem, which is just really a result of your interaction with the building, understanding of the building diagnostics and pathology, and your core values on what we are trying to achieve. Once that framework is defined, modeling analytics come later.
One of the shared missions that many real estate professionals around the table are thinking about right now is this what seems to be an unsurmountable challenge of decarbonizing our buildings. I have a question in two parts. One is, help me demystify. If you double clicked into what does it mean to decarbonize buildings? If you help me double click into that. And then the follow up is, do you find that the modern buildings, as opposed to older buildings, have a kind of a different ratio by which they're contributing CO2 in the atmosphere? So help me demystify carbon in our buildings.
Wow, that's an insightful question. And I'm glad that, we are talking about this. Decarbonization what I understand in its basic sense is that let's not waste energy from our building stock. So in other words, try to have our carbon footprint in the ways we expend energy on buildings as minimal as possible. Now, we expend energy on our buildings in two ways. I think one, the industry likes to talk about it as embodied energy or embodied carbon, operational energy, operational carbon. And they're great two buckets. Operational energy is very well understood. It's like, the kind of appliances we use, the kind of HVAC and other, mechanisms, hot water, things related with services, building services. The other is the embodied carbon, where how the building envelope is performing. And I think it's connected because if it's a leaky building, it's going to have a higher operational carbon. If we just start fixing the buildings with incompatible, unsympathetic methods, it raises that embodied carbon threshold bucket in some ways, because here's where the confluence of sustainability lies, because sometimes it looks like something that's readily available, or something that is some material that is, let's say, environmentally more sensitive, might not be compatible with this building, but it's used in that building for repair, but it didn't enhance the durability of the building, hence the building carbon value declined. So that in that regard, how do we maintain our buildings to provide these machines, well-oiled machines, which are using these operational carbon in a manner that we would like it to be used, that there's no wastage. I think that is the interaction between the two that our industry is not really talking that much right now. So decarbonization to me is a good marriage between the embodied carbon and the operational carbon. And in that sense, one needs to work very well with the other.
Do you find that there's correlations or parallels between older buildings versus newer buildings, maybe drawing the cutoff line at like modern buildings? Is there any ancient wisdom, for example, that, or maybe there isn't, about just embodied carbon combined with the operational carbon you found in a building's kind of age?
Right. Older buildings, more vernacular in nature, very empirical ways of building the buildings. And there was less of, values in that sense. We're still understanding those kind of values on how to calculate the embodied carbon. The industry has not caught up because it's complicated to calculate a carbon on an existing building that has been in service for 100 years. Some of those materials, like in the 60s and the 70s, the much older buildings were created with much natural materials. So even if we don't have values, we have kind of understanding of those materials, and the fact that the end of life destruction for those natural materials, brick, stone, cements, is far in advance. But some of the more synthetic materials here that kind of came into existence later on have a shorter lifespan in that regard. And injecting more kind of durability into that is complicated. The buildings that we make now are easier to calculate in terms of, giving them values for embodied carbon. They can be designed for circularity or, so they can be designed for sustainability goals, right? The values that we provide for, or the rating system that we provide for LEED or something. With older buildings, since they did not exist with those values, they did not have that purpose, or they were not fighting the same battles that we are fighting now. It's not a real apples to apples comparison. A good underlying principle for an older building is to, in my opinion, and maybe others might find an urge to disagree with me, and I would invite disagreement, is that for an older building, when there is this lack of calculation, I'm not a big fan of calculating or putting numbers to everything, because a thing that's in existence, putting a number to that is insufficient way of understanding that building. I think a sufficient good way of understanding an older building is to understand their materials completely, understand their assemblies completely, and find the ways to make it durable instead of quote unquote sustainable. An existing building already is a sustainable endeavor. This endeavor right now is to make it durable so that it can endure another 100 years of its life. I think that is a fundamental shift in the principle that I think is missing in our conversation for an existing building.
I love the way you frame that. I think that's perhaps one of the first times I've heard a specific angle perspective on what sustainability is. Even dating back to my own college experience in architecture school, at this point, everyone has grown up studying and designing and working in a field where sustainability is a given. But oftentimes I find that the word almost kind of dilutes in its nature, just because I guess of the different ways to interpret this. Sometimes folks just kind of devolve it to just kind of satisfying the certification or a checklist of some sort. But thinking about it is almost like the durability of a building, like how long will it last? And by definition, it's sustainable is a fascinating framework.
I want to add something, strange to this is when I started hearing about, oh, we have to make this building with these sustainability goals. And I used to think that, well, so do you mean that there are buildings we should be constructing without the goals? I mean, is there a different set of thinking principle that should even be allowed to exist? Because I think this really should be clockwork for us in like our regular thinking. There's no sustainable thinking. This should all be one thinking. However, maybe we forgot as our industry forgot that there were these principles that we were to design for. And I think sometimes we forget, it becomes a checklist of sorts and not really thinking of sorts. And that's the part I don't kind of like. But the fact that now it's regulations are taking place, I think it's all steps in the right direction. I feel really grateful that I'm here at this point in my career, seeing all these tides of change happening, and I'm there, and there is my voice that can add something to the discussion. So it's a great time to be thinking about these things, because I think we are standing at that inflection moment in ways, because this is where we kind of set the tone for the next 100 years.
Yeah, I often like to finish with a question. With all of the emerging technologies, all of the emerging regulations, much has evolved over the years, the decades, hundreds of years, building buildings. But in your case, you have a unique perspective that you're often looking at really, really old buildings. I'm curious, do you find that in 5 or 10 years, we have no idea what kind of technology we're going to be looking at or considering as part of the workflow, but in 5 or 10 years or in 20 years, what is likely not going to change about our buildings?
I would start with that what's not going to change is that the AI, use of artificial intelligence, is not going to be less. It's only going to be more involved, more deeply involved, not only for basic data collection, but, analytics. And I'm excited about that, frankly. What's also not going to change are basic design principles, basic engineering principles, and basic understanding of materials and assemblies, diagnostics. So I think what I would like to see more in the things that are not going to change is more involvement of science in our discussions, because at the end of the world is what we do is built world. Built world is composed of materials with specific chemistries, and chemistries can only be either compatible or incompatible in the settings that they are supposed to exist or they are meant to exist. I would like to see more of that in the things that are not going to change in the coming few years, many years.
Amazing. Charu, this was a really fun conversation. Thanks again for joining Buildings 2.0.
Yeah, absolutely. I had a lot of fun. Thanks.